Examples on refraction of water wave. Number 1, Part A. When the water wave travels from the shallow region towards the deep regions, the speed of the water wave V1 changed into V2. Since the speed of water wave increases when the water depth increases, therefore, the speed V2 is greater than that of V1. As a result, the speed of the water wave changes. This phenomenon is reflection. When the plane wave front reaches the boundary, the wave at the edge travels at a greater speed, and the wave still in the shallow region will travel at a smaller speed. Therefore, the new wave front in the deep region will be something like this. Also, the wavelength of the wave in the deep region is longer than that in the shallow region because the ratio V1 over V2 equal to lambda 1 over lambda 2, since the frequency remains the same. Question number 2. When the wave propagates outward from the dipper, we see the wavelength of the wave lambda decreases, which means that the speed of the wave decreases. Since speed of the wave is related to the water depth, that means when the speed decreases, which means that the water depth also decreases. Hence, the ripple tank has the shape like this one. And the dipper is at the middle. When the dipper vibrates, the wave travels towards the edges with water level, and the water depth decreases as the water wave traveling towards the edge. To reduce the effect due to water wave reflect by the edge of the tank, we may use a ripple tank with a sloping edge, or we may add some sponge on the inside of the tank to reduce reflection. Number 3, the frequency equal to 1 over period equal to 1 over 5 times 60 seconds, which is equal to 1 over 300 Hertz. Wave speed equal to f lambda equal to 1 over 300 times the wavelength is 100 kilometer, which is 100 times 10 to the power 3. The answer is meter per second, which is equal to 333.3 meter per second. For part B, since water wave is a transverse wave, therefore both A and B will move up and down, or we say A and B vibrate vertically. For part C, the water wave traveling towards the shore initially have constant wavelength. When the water depth decreases, the wavelength of the wave decreases. Question number 4. The wavelength of the wave in region A is equal to 20 divided by 1, 2, 3 cm, and the wave speed in region A is equal to frequency times wavelength, which is 10 times 20 over 3 cm per second. The speed of wave in region B is 1/2 that in region A. Therefore, the speed of the wave in region B is V equal to 10 times 20 over 3 divided by 2 meter cm per second. Since frequency remains unchanged, the wavelength of the wave in region B is also half that in region A, which is 20 over 3 divided by 2 cm. Since speed of the wave in region B is smaller than that in region A, therefore A is deeper. When the water wave travels from a deep region into a shallow region, the speed of the wave decreases. Hence, the wave will travel towards the normal. Therefore, the water wave in region B will be something like this one. Notice that since the speed decreases, the wavelength lambda also decreases. Question number 5. Part A. Wavelength of the wave in region A is lambda A equal to 6 over 123 equal to 2 cm, while the wavelength of the wave in region B, lambda B, equal to 9 divided by 123, which is 3 cm. By the ratio VA over VB equal to lambda A over lambda B, we have 15 over VB equal to 2 over 3. Therefore, speed of the wave in region B is equal to 22.5 cm per second. If the frequency of the vibrating source is doubled, since the speed in A and B remain the same, therefore the wavelength in A and the wavelength in B will both decrease by 1/2. Therefore, the new wave in A and B would be something like this one. And in B,